Hello. So, welcome everyone. We better start to save time and maybe others joining shortly. Clem, can you hear me well? The sound is okay?
Yes, I can hear. Thank you.
Okay, no problem. Yeah, let's start and I think we'll just join from introduction. So this webinar is just webinar series we have every season, quarterly, to connect with our clients and also educate our connections. Today is behind sense of a CFD report. So we try to educate our audience with process. It's not technical because I'm not teaching here CFD. Just we want to know that when you order a CFD job and the result is report, what's behind that, and this understanding helps to smooth run, in CFD projects or how to help. Anyway, agenda we are covering is definitely introduction, and then CFD process overview. Just we try to overview our process, and to application and case study. Just we review and future of CFD. And definitely, I love to hear your feedback and also your challenges to help for future webinars or project, whatever is very valuable for us. So who we are most of you worked or is working with me, and we are a small company focused on professional performance solution and basically CFD core, but we are also doing energy modeling, fire and smoke, acoustic, and some facade analysis, thermal and condensation risk analysis. This is our website, www.deratec.com.au, and feel free to visit and keep in touch to any question you have. So again, you know me. My name is Sharam. Shah means king in Persian language, but my nickname in Australia for easy communication is Sean. So you call me whatever easy for you. Have PhD in mechanical engineering and definitely experience overseas. I was professor uni in IUSD in Iran, and also same time in industry named Farab for a long time, maybe around more than 10 years or even more. So then moved to Australia working for Iricol, natural ventilation company for 3 years as a CFD engineer, and then Lendis, well-known company, again, CFD engineer. and then moved, established, and as a co-founder of Deratec. Qualification, bachelor, master, and PhD mechanical engineering. And yeah, 20 years, maybe 24 now, 2000 years in CFD and mechanical engineering, both combination academic background and industry. So let's start from here. What's computational fluid dynamics, CFD? So from words, it is something, is digital, is not, as is computational, and fluid, so something moving, fluid is not solid, and then dynamic is, movement. So we have three cores here for one CFD. The first definitely is fluid flow problems we call Navier-Stokes equation, and is fully mathematic. I don't want to, show you in word because I try to keep simple. But anyway, I will try to add some theoretical or whatever, on website if someone interested to learn more. Definitely energy equation. We can add mass, heat transfer, multi-phase flow, and a lot to these equations. These equations hard to solve, but thanks to CFD, we can discretize the environment, or we say domain, to calculate velocity, pressure, temperature, concentration, humidity, and so on, whatever parameters involved in our problem. So early 80s, the first CFD software or first commercial CFD software, Fluent, came to market. And from that, around maybe 40 years, yeah, CFD improved. And then in parallel with software, develop, we have hardware developed too. So imagine from, I don't know, you remember Pentium computer. Now we are talking about cloud computing or HPC, very, even your laptop is now is, one HPC cluster, is 8 core or 12 core, whatever. So huge improve in hardware to happen. So software is divided three categories. One, open source, same as OpenFOAM, safety free, whatever. They are free, so you can access and simulate, but definitely they are not reliable because no one behind that. Commercial, most familiar is ANSYS, and a lot more. And specialized, maybe limited, but specialized for somewhere same as Autodesk CFD. We'll talk more about the softwares. Just this few. I'm not saying here I'm covering all softwares CFD softwares in the market now. A lot more in the market, but just I selected some as example. Other CFD that we are using is user-friendly, great for building and especially HVAC. So it has challenges limited in advanced turbulence, but design focus project. So it is very good for industry application. ANSYS Fluent, well-known, and ANSYS CFX, sorry. Highly accurate advanced simulation, but expensive. Steep learning curve is not just user-friendly, a lot of module, and is very difficult, and is best for complex simulation, more academic or cutting edge, or if industry, we have something very, special case. OpenFOAM, I said free and open source. It means free, but require programming expertise, and addition to CFD expertise, you need to Python or whatever, and then it's customized application again. Just, you can use OpenFOAM for very simple jobs or complex physics and customized one. Star CCM is for multi-physics, so it's when your phenomena is complex, very costly, and high fidelity simulations. SimScale, just recently came to the market, maybe last 5 years. Cloud-based, easy access, is not expensive, but required a strong internet connection. The Europe-based. So early stage design analysis is not deep, and you can't, use it for project, just estimation, roughly. So maybe it's good. FDS, maybe you heard a lot. Fire Dynamics Simulator is specialized in fire and smoke. We will talk about that. Limited to fire related and fire safety and smoke. I saw a lot of report using for car park ventilation. I don't recommend. I will discuss later why, but it's excellent for fire simulation. So how to choose? Again, depends on the application you need to use and also budget, a lot of, parameters and operator expertise. For example, learning new software is timely, especially complex one. So here in Deratec, we are using Autodesk CFD for reliable, cost-effective building simulation and FDS for fire and smoke. So how does CFD work? So first of all, we need to define project requirement. Identify, for example, when I'm just using ventilation as an example here. Identify ventilation needs, goals, and compliance with NCC or AS 1668.2. So we need one define, for example, car park or whatever we are looking after. So client or who is looking after send you something like that, one plan, maybe some, for example, here jet fan or supplier, whatever is it, just initial design, just try to what the goal is, just first meeting standard, and second and most important is saving money, saving costs. Don't forget, we are using CFD to save costs for our client, not just adding costs. So next step is create a building model deemed to satisfy, for example, is from NCC, but we are looking for performance solutions. So first we develop 3D model of space, including key feature like vents and equipment, whatever project is, we assign geometry. And then, for example, very simple car park, very simple, that car park, we are assigning, passes and emitters, CO emitters and jet fan. Entrance is natural ventilation, so no supply, whatever. And you can see that this here is jet fan and CO emitter as a car. Car is moving and, we have CO. So depends on the project, simple or complex. We need to convert drawings and project input to this 3D model, but simple one because CFD needs simple geometry. Then we start CFD modeling. First is boundary condition, set up the model, mesh generation, and then all method we want to transient, residue state, a lot here is a big step. So needs expertise, needs knowledge. Everyone just claim I'm safety engineer, can't do it. You need to have experience, you need to have knowledge, especially experience, not just safety, experience in that field. For example, if someone now comes to me to do safety for biomechanics for heart, definitely I can do. But if they can find a safety engineer with biomechanic background, definitely he or she can do better. This is important. So, for example, I'm not just safety engineer, I'm ventilation engineer or mechanical engineer. So these two can help to the final report be very practical and high efficient. Normally our reports straight away, approved by client or consultant engineers because we know what to do. So here is the domain. We for solving that Navier-Stokes equation or all equation, we need to discretize the domain, and each cell or node needs to solve by software and definitely hardware. For example, 2 million, 3 million meshes, and this is the reason it takes time, from a few hours for simple geometry or simple problem to the maybe, I think, for wing comfort, we simulated for whole Sydney or part of Sydney. It took around 72 hours with cloud, with Google Cloud, not just my computer. So it was around, if I remember correctly, around 30 million meshes. So it depends on the complexity. Yeah, time will be different. This is the reason price also is different. This is time involved. So then we have post-processing, we have some analysis, and we need to have a look. If we need optimize, we change geometry, we change parameters. For example, jet fan position here, or adding jet fan or decrease, and then getting the best result to meet standard, and also again saving cost, because we don't want to add cost to the project. In some cases, yes, because for example some struggling happen, but most of cases we need to save money for our client. So yeah, we have some result. For example, here the velocity, how velocity move, and where is the high velocity. We can have a look. Depends on the structure or whatever is it. We can judge and is it okay or not. Again, here expertise is very important. This is the reason I'm saying ventilation engineer need to do CFD engineer, wind engineer need to do CFD for wind. So this is the reason when we want to interpret the result, yeah, we need experience. And then report and documentation. Definitely, it can be very detailed report, depends on the client, or simple report. Some clients prefer simple keys strategy, just keep it stupid simple for understand, sorry for the word. And some no, they like, if they some clients they think is right or wrong, and I'm not judging. Professional report is mean detailed reports. I'm not judging. Anyway, depends on the client. Report can be very simple to the very detailed report. Yeah, this is just example safety, and then yeah, report number sending to the client. So benefit of safety. Again, the target is saving money, higher efficiency, and sustainability. So this is the three main we need to consider when we are doing a CFD report. First, starting from design. Normal design by consultant is deemed to satisfy, not optimal design. This is expensive solution for contractor or builder, and they call 70%, 80% design. So, and we know most of them copy from other projects because they don't want to spend time and just leave it to the contractor or subcontractor or supplier to do the rest. So definitely most of the project we need to have a look, spend time to optimize. For what? For saving money, higher efficiency, and definitely system. So we propose a design, client purpose, or we propose a alternative design or performance solution to meet this goal. And what's the tools? NCC accepts safety analysis as a verification of this design. So again, we need someone, knowledge, experience, and qualification to be able to certify chartered engineer or air engineer or practitioner for class 2 buildings, for example. And then we have outcome. Outcome can be deemed to satisfy again, but saving money, performance solution, alternative solution, cheaper solution, verify of detailed design. Sometimes we are not looking after saving, just we want to verify, the design. We have, for example, a fussy consultant engineer, and he or she wants to, see, verify her or his design and higher performance or sustainability. For example, you want to meet Green Star, getting Green Star certificate, higher one. So your solution is not meet with that. So we review and we help you to reach out. So every good things also have limitation. This is, it says the word. We don't have perfect things. So CFD also has some limitation. Most common limitation is resource requirement. My challenging when talking to clients is that they're struggling to pass accurate inputs. So when we have accurate input, I'm talking here, definitely we can lead to the reliable data, and unreliable lead to reliable. So this is very important. When we start CFD project, all information pass to the CFD engineer. And resource requirement, yeah. So hardware is challenging, but I'm not worried about that because a lot coming. We have cloud base, and hardware is improving a lot. So now is not a big problem. Maybe for a very huge urban, or something very huge mesh or very tiny mesh we want to use. So this is not for ordinary job problems, and this is just for big problems. And assumption during simulation is very important. For example, to decide, okay, going to steady state or transient, or you need to validate, your assumption. Is it okay? The result is reliable or not? Because always we are simplifying. We are trying to optimization. It means you get good result with simple. It's not, it's not worth it making the problem complex to get result. No one likes that. Human factor is very important because operator error, it has a major effect on the report. So this is the reason, again, you need to deal with professional safety engineers. For example, a lot of energy or environmental engineers, they claim about safety, but I'm saying that just be careful, because just they are trying to do something for you, but not enough safety background. They are good in energy modeling, but not safety modeling. Again, interpretation to the data, to the report is very important. Again, you need to have experience to see that, okay, how to cross-check your safety. Is it valid, aligned with theory, or if you have physical tests? So you need to judge you are in a good position or not. And definitely simplify geometry, because of mesh is the big challenge. For example, FDS they are using, it is just developed 10 years ago, is free, and to use that you need to apply very simple geometry. This is the reason most of the time the result is not reliable. For ventilation. For fire, yes, because for fire we are different story. We are looking after just the movement. But when you want to see temperature, you want to see CO or velocity, whatever, it's not reliable. The reason is very simplified geometry, and also turbulence model, large eddy. It means it captures large eddies, not small eddies, and ignored all the small. So yeah, this is important. We have some meshless software, same as Xflow, using lattice Boltzmann, but is another story. But definitely in the future, we don't have problem for simplified geometry. I'm pretty sure solution will come will become by software development, safety software developers. Future of safety. So I started CFD 2000. The first code I wrote, it was, and then in the same time I bought this Nokia phone. So in 2025, I'm here for you, and we are talking about iPhone, smartphone, for example, iPhone or Samsung, whatever, 16. So traveling in 25 years in, for example, phone industry, getting from this phone, very, very good phone in that time, reliable phone Nokia, it is fun. But the question is that in 2015, what will happen for example, phone industry or communication? Maybe each of you have an idea. I don't know. So similarly, yes, I said 2000, just I wrote 2D code with Fortran for NACA 0012. It was very challenging, just with Pentium, a lot challenging to get this, simple result that now I can do for you in 1 minute. 2025, for example, we are able to 3D simulate for airborne, wind simulation, even more complex. And again, question, what will be happen in 2050, in 25 years? So this is important to know because as a safety engineer or you as a client, what's happening in background in safety development. So this is some ideas, we can talk about it. Definitely AI driving safety softwares will come and optimize. So more intelligence, less human interdependency. So yeah, process will be decrease, prices decrease. We will see what happen how AI can help safety and also trade safety, because all the time it's not, if you don't, move with technology, you will, stay back. So also integration with IoT, for example, real data, installing something, it is my favorite one, smart building. So it will be happen a lot in this area in future. For example, you can see in the same time with one glasses or your phone, you can see real CFD, look at the LOVA, for example, and you see that airflow come and what's the simulation and where it's going. No need, ask, call me, Sean, can you simulate for this for me? No, just with some simple app or, simple glasses, you can see the real, phenomena happening. Okay, maybe it's not 100% accurate, but 50% enough because you want have an estimation in your design or installation of the stage. Cloud computing will be worth a lot of data centers developed by Microsoft, Google, Amazon, and a lot. Even as safety companies, same as ANSYS or Odex. So we have a big future in this area. So hardware is not the problem anymore. Automation in design process, we need to, we use, when I was in Lendlease, we used a lot. So a lot of same problem, we can automate it. And so no need, every time engineer or safety engineer involved. And then just, in automated way, the problem solved, just maybe geometry or parameter, changes. And definitely improve reliability and accessibility, both of them. So because now to get reliable results, you need rely on experienced safety person. But when you are using, for example, AI on future, maybe just you can use graduate safety engineer, or even you can use by yourself. So we will see what happened. Is just some foretold, not 100% what I'm seeing now. Maybe some of them I'm wrong, or we will see what happened in CFD. So yeah, you're all familiar with DTS and performance solution. DTS is just something is fixed. For example, again, ventilation, if as example, fixed ventilation rate, straightforward, rely on standard. So very limit, but and no innovative, but easy, very easy. But performance solution in opposite, customized approach and using advanced analysis, innovative, sustainability, saving costs, everything involved. But we need to show that our performance solution is at least equivalent or better than DTS provision. So yeah, it's short table. So approach, flexibility, tools required, and suitability. We can see that DTS is very simple and easy to apply, but performance solution is higher performance, higher flexibility, but cost involved for safety, but a lot of cost saving. You will see that in our case study, how safety can help you to save money. So yeah, safety application in buildings. We have two categories in buildings. One, indoor, HVAC, ventilation, thermal comfort, air quality, energy efficiency. It can apply for office, school, hospitals, data centers, car park, kitchens, green buildings to achieve green stars, plant rooms, stations, warehouses, a lot, and battery storage. We worked with Toshiba in this field recently. So yeah, for example, this is smoke or CO level in a car park, 3D animation, whatever we can do. And definitely outdoor. Main is wind study, wind load and wind comfort, but it can be again energy efficiency, for example, facade or sun, and then rain and water. We are able to simulate rain and water penetration for facade or window or louver, and pollution, dust or just normal pollution, whatever, environmental, we can apply it outdoor. Definitely in this area, we need higher cluster, higher hardware because of very wide geometry. And for example, this is a tower, and we are simulating wind around that, and we see how turbulence or intensity and velocity is around the building and effect, especially for neighborhood buildings. So case study here is just car park safety modeling. We have a car park here. This is a drawing and initial design where with 18 jet fan and different positions and also different amount of supply and exhaust. So we reviewed it and is I think 252 parking spots, just one level. So 2 supply and 2 exhaust fans, very huge fans. So initially it was 18, I said, and fresh air intake from supply and definitely going from exhaust. Also parking ramp is a supply air that we are using normally. When engineers design, they ignore this, but when we are doing safety, we can see how much parking ramp help to decrease supply fans, and this is the benefit of safety. So air circulation in car park facilitated by jet fans. You can see these red ones, and exhaust via ramp or exhaust fan. 50 Newton jet fans were selected based on initial design, 18 of them. So what we did, we simulate and then recalculate, optimize the jet fan quantity and position, and also air calculation we decreased air. So jet fan decreased to 12 from 18, and to keep 1 hour average CO 45, that the code says 60. So we behind that, I mean, we under the criteria is good, and 1 hour maximum 85 is still best. It's good. So solution compliant with NCC 2022 and when AS 1668.2 2012, and client gave back just feedback around 30% cost reduction based on outcome. So both fan sizing, riser, and also jet fans capital price, and also installation. And definitely long-term run is not including, but less jet fan, it means, or smaller fan, it means less electricity. So a lot helps. So here you can see that is the car park is multi-level, is one level, but different levels. So very complex geometry. We try to add or consider all column, and it's all jet fans. Here you can see jet fan. And is worth it to explain here some safety engineers and reports I'm seeing that they are using just one pressure or one velocity as a jet fan, or for example, when we're talking about louver, always I'm using the real louver shape, because if for example louver is one stage push airflow up, is two stage double stage pushing down, but normally they are using just one pressure, one very simple, and just adding pressure drop. So it's good for estimation, but if you want to decide about ventilation, is not good idea. So be careful when reporting to you, because I reviewed a report done by a big consultant. I don't give your name because it's recording. And when the supplier asked me to peer review, I was shocked. I was shocked because supplier recognized, because they have experience, natural ventilation experience, they recognize something is wrong with outcome. So they asked me as a third party to judge, and it was terrible because they didn't understand natural ventilation well. They applied all wrong. And anyway, I think problem solved after commented, and they changed the report. But I'm saying that sometimes you reach out to a company, very cheap price, but be careful, because they don't know what to do, you know what I mean? And they're trying just to get a job. And definitely the result, for example, CO level, here is it. So I'm trying to catch the time, give you around 10 minutes if you have a question, because I love to hear from you, just not I'm talking. So in other case studies, factory thermal comfort is rely on completely natural ventilation. So this is without any ventilation. Definitely red means very hot, and or maybe very small ridge vent here. But then we're adding some roof vent and louver, for example, some louver here or whatever, adding. And initial design, is not showing comfort, but optimal ventilation, we can reach out thermal comfort, human occupancy, especially in warehouses, is very important for efficiency, machines efficiency, and also labor efficiency. Both of them is down based on ASHRAE 55 standard, thermal environment condition for human occupancy. And yeah, we're talking about PMV and PPD. So definitely, if they want to use mechanical ventilation, for example, fan is very huge capital and also running cost. But here, cost reduction achieve a 10% reduction in running cost, efficiency improvement, and definitely reducing carbon dioxide. So increasing ability to get Green Star certificate, higher higher rated. So we can see that this is before and this is after design. And we can reach around 5 degrees above ambient, but before is very hot and it's uncomfortable for. So we have here psychometric chart, and we can see that this is comfort area recommended by Ashraf for offices, air conditioning, not warehouses. But here we were, but we close to this area, so we can see that we can close to the recommendation by Ashraf by natural ventilation. So this is rely on louver and roof vent. And if you send this report to the client will be satisfied because you explain with some verified method, especially third party person. So this is very important for salesperson how to use CFD to get big project to satisfy engineers or consulting company. So yeah, here is that the temperature was, for example, in a standing level, it was around 13 to 28 above ambient temperature, but after applying design, CFD shows less than 8 degree. So it means 4 or 5 degree in average, depends on different area. For example, here is very good lower side, but here is higher, so we're talking about average. So this is important to know that how uses CFD for marketing or for sale is not. This one is not the first case study was for performance solution to get NCC meet NCC, but this one is not just for NCC. Can be used for Green Star, but it's more for marketing or sales purpose clients to show that what's happening with CFD. So what we learned here is the first and most important is that CFD enables sustainability and cost-effective design. Again, this is very important because when client, you or you are CFD engineer or your client, when come to a CFD engineer, giving cost, it means adding one cost to the budget, whatever is that, project or code. But what's the gain? Is that cost-effective design or sustainability? You can't just add problem to the problem. So this is important that when we are talking about CFD application, some engineer just, they want to get best result technically, but it's okay, good. But we are talking about optimization. We need to look after our client and stay balanced between cost and accuracy or efficiency. So this is important to know that, and this depends on the CFD engineer. It's a very key person, can save money for you or just kill your budget. Reliability required quality input. Again, a lot of project when we start, we ask for information. Maybe it's not available or parts. So this damage, the outcome. So this is important. Client try, his or her best to gather the more reliable and complete input. Then CFD engineer can apply all of them to his or her model, and then the result will be reliable. Again, operator expert is vital because skilled operators minimize error and improve accuracy. So this is again important. Who is writing final report? Because report it can be simple or detailed, doesn't matter. We are not talking about length of report. Report can be just 2-page, but very practical. Again, cost effective and sustainable. And report can be 100 pages, but useless. A lot of unnecessary details and not practical. So this is the reason, in my opinion, doesn't matter how many pages. It is important what is inside and what's the outcome. And another most important is that changes affects timelines. You saw that, okay, we need geometry, we need input, then assign, then optimize, then the result. So any changes can, stop or hold or add more job or more time to simulation. I give you an example. I was doing wind loading or wind pressure calculation for a dome for my friend, my ex-manager, very good relationship. Anyway, in coding time, we code for 4 direction or maximum 8 directions. But when we're talking, he asked me for 16 directions. And I wanted support, but I couldn't increase price because already he quoted to the client. So I did 16 direction, wind direction for him, and definitely my job got double. So I did, but I just used my time for support. Okay, our partnership or long term worth it, but I'm saying that this is important. Every decision in code time, very clear, and don't compare two CFD codes easily because one is more accurate, more time, scope is complicated. One is just maybe just a basic or rough. So this is important when someone quote you CFD is not just selling pen, is very high technical. So back to a safety engineer or company and discuss what's the scope, why price is high or why price is low. So, and then make sure you are in same boat. You are understanding what's going on and what's your expectation, and they understand or they are not over, what's that, over understanding or less, under. So this is important and essential. So yeah, for any question, anytime, just reach out from email, design or Sean@deratec.com, and my phone number. Anytime, just text me or phone me. I'm available. And also you can just, click deratec.com.eu or follow us on LinkedIn to, to learn any question, even is not project and you need, just know my opinion. I'm available to help. And now, it's your time. You can ask any question. We have around 10 minutes. So just you can chat, text here for chat, or just unmute yourself and talk, whatever comfort for you.
I'd love to hear from the other team, see what they reckon. But just had a quick question on IES, the I think it's called Integrated Environmental Solutions. Do they have a CFD style thing? How does that rate to those other ones that you presented at the start?
Say again, what for what?
The IES VE Virtual Environment program that's available. How does that relate to those other CFD programs that you went through?
Yeah. A lot of EIS, a lot of programs, same as EIS, energy modeling. They are the core, but they have some very simple CFD. So they are showing, some estimation. Definitely, they are not reliable now. Maybe in future they can develop, more, or for example, they linked with ANSYS or whatever, so they can give you more. But if you want to just code or something marketing, just show is okay. But if you want to get decision, based on that report, no, definitely is not reliable.
That's good. How do you determine the mesh needed for a CFD?
Yeah, we call mesh independency study. We need to do this in study for every project. For example, just that three enough, one, normal, one less, and one high. And we need to see that not, for example, 5% or 2%, different between pressure or velocity between these three. Then if we say, no, steel is changing, we need to go higher. Or if it's not changing, it's better, less simulation. I'm doing for every CFD work. Yeah.
That's good. Don't want to use up all your question time, but what's your current view on the market?
Current what?
The current view on the market going ahead.
You mean CFD?
Yeah, just the building market and construction and ventilation.
Yeah, you know better than me, especially NCC 2025 is coming next year. There's a lot rely on performance solution and, engineers. So market is very, very thirsty for, performance solution. I'm talking about general. But when back to ventilation, yeah, for example, I had recently, I don't know, notice here or not, recently for Paramata, for substation, they relied on mechanical ventilation, but I used LOVA, fully natural ventilation. I showed with CFD, and the client or consultant accepted. So, so it's huge change for them. For example, big fans or ducts. So some client, contractor, supplier, they are very very passionate, using engineering and safety to save money. So it's good, and I think they need to educate. And in 2 years, I started. This is one of main purpose of this free webinar. Educate each other, and I learn from your feedback, and then yeah. But I think ventilation, especially using natural ventilation, because of sustainability and greenness, that is more and more coming. Yeah.
Thanks for that. I just had one more question, just on your acoustic testing.
Yep.
Do you use CFD for that, or have you designed something to do acoustic testing?
Yeah, we are able, modeling acoustic is not is a part of this this free webinar, but acoustic, yeah, we are using AS 1191 standard for 1/3 octave for 18 frequency, whatever. So to reach out RW. So also we are able to optimize. For example, again, I can't give you a name, but recently with one LOVA company, I'm optimizing their LOVA to reach out, because the problem is that in medium and low frequency, the STR or insertion, insertion is very low. It's normal for LOVA, So we redesigned, and now we reach, higher. So this kind of jobs, yeah, is coming, or some acoustic panels. One company came and I did a lot for them. So yeah, this is modeling. Acoustic is a bit different because it's not project based, it's product based, whatever I did. But maybe in future we involve in more project, for example, one auditorium or one salon, building, to see what's happening.
That's excellent. Appreciate your discussion on that. That's very helpful.
Thank you. Thank you for your question and your time. Any other question? I think if you go,
that's all I had for today. Appreciate that.
I think we wrap up because I think everyone left. So yeah.
Yep. Thank you very much. Good on you.
Yeah. Say
Thanks,
hello.
Sean.
Yeah. Bye.
Yeah, bye.